Try to solve another Leetcode problem. 1458, maximum dot product of two subsequences. So let's first understand what is the dot product of two subsequences. So according to the description, if we are given an array, for example, that is 2 with minus 2 and another one. So for example, I just choose an example to explain what is the dot product of two subsequences. So they must have the equal length. So this length is 2. Another one I'm going to choose a 3 and minus 6. So array 2 is also 2. So the length is also 2. If they are equal, so what is the dot product? It is 2 times 3 with minus 2 times minus 6. So it is 6 plus 12. So this is the dot product, 18. So if this is subsequence and this is subsequence, they get a product of 18, and 18 is the maximum. So we're gonna return this result. Yeah, but how should we solve such problem? Normally, if we are given two string or two nums array, and we are going to check if the distance of them are equal, maybe it's gonna be a LCS problem. So it means the longest common subsequence problem, because they have the equal subsequence. For example, they choose 2 minus 2, another one is 3 minus 6. They choose the two subsequences. Yeah, maybe it is different, like from AB and AB. It is similar characters, but currently it is a number. It is a little bit different, but it's the same idea. So this is the longest common subsequence. But for our problem, even it is a number, it is still a longest common subsequence problem. So before solving this problem, let's make a drawing first to understand why we can use the longest common subsequence pattern to solve this problem. So let me make a basic drawing. So normally for solving the longest common subsequence problem, I'm gonna make a drawing and I'm gonna prepare a pattern. Yeah, because this pattern can save me a lot of bugs or can save me a lot of edge cases to check. Yeah, so for my pattern, I'm gonna prepare always the negative infinity. So these areas will be the negative infinity. Yeah, so I'm gonna prepare the row and column. So now nums1 gonna be my row. So for nums1 here gonna be 2. But I will not choose so many numbers. I will just choose 2 arrays to explain. So 2 and minus 2. I'm gonna prepare a 2 minus 2. And for the column, I'm gonna prepare 3 minus 6 maybe, because it is a little bit shorter. I can save some time. Let me just clean this area and prepare 6 and minus 6, just to explain the idea of why we can use the longest common subsequence to solve the problem. Yeah. So currently, we have a table. So in this table, I'm gonna explain the longest common subsequence idea. Yeah. So for the pattern, I've always prepared a negative infinity, because I'm going to check the longest common subsequence. I'm going to check the maximum dot product of the two subsequences. So normally it's going to be the maximum number. So for the patterns, I'm always prepare a negative infinity, and then I'm going to check how many different cases I can get from this nums1 and nums2. Yeah. So for the first position, while I choose a number, so which one going to be the maximum? I mean 2 times 3 is 6, or maybe it is a minus I, or maybe it's this minus I, or maybe this minus I plus 6. So what is the maximum? So it's going to be 6. Yeah. So this comes to the idea. So if we have two arrays, S1 and S2, so the dpi and z means for the nums1, the distance is from 0 to maybe for let's say for I, yeah, and for the nums2, the distance is from 0 to, I mean all the numbers, it is from 0 to z. So if we want to calculate the fi and z, so this is the dpi and z. So what we can get? So we can choose some numbers, maybe we're gonna choose from 0 to I minus 1 with z, or maybe 0 to z minus 1 with I. So those are the two different cases. It is this one and this one. Maybe there's another case, so we're gonna choose this number and this number. Yeah, so it means 2 times 3. Yeah, but maybe the previous dp I minus 1 and dp z minus 1, maybe it is smaller. Yeah, maybe it is smaller, maybe this is positive. I'm gonna choose the nums I times nums z if it is positive. Yeah, but if this one is also positive, maybe I can get an even bigger number. So this means another case is this 6 plus the dp I minus 1 and the dp z minus 1. Yeah, so this is the formula. So it is from I minus 1 to z. This is one case. Another case is I to z minus 1. This is the second case. And another case is I minus 1 to z minus 1. And we need also to plus the nums I minus 1 and nums z minus 1. Yeah. Or maybe we don't need to plus. It's going to be directly nums I minus 1 and nums z minus 1. So that will be all the cases. So for example here, we're going to check the next number. Yeah, so this is a 6, this is a negative infinity, and a negative infinity plus this is going to be minus 12. Of course, here going to be 6. Yeah, and what about this number? So minus 2 times 3 minus 6. So this is a negative infinity, negative infinity. Of course, I'm going to choose a 6 because this is going to be the maximum. And let's check the last one, minus 6 minus 2, it is 12. 12 plus 6, it is 18. So 18 is bigger than all other cases. So my final result going to be 18. So this is going to be the final result. So it's going to be f minus 1 and minus 1. So this is going to be my final result. Now let's get back to the coding to finish it. As I explained, I've always want to prepare a padding for this kind of longest common subsequence problem. So it's going to be length of the nums 1 plus 1, and for the column, it's going to be the length of nums 2 plus 1. Now I'm going to prepare the function. Basically, it is a dp array. So it's going to be negative infinity times the column for r in range how many rows. Yeah, so this is my dp. Now I can get started. So for r in range with capital R, and for c in range rows with capital C, so I can get my final result. It's going to be dp r and c, but I need to start from 1 because I've already prepared the padding. I don't need to check so many edge cases. Yeah, so it's going to be the difference of the 4 result. It's going to be dp r minus 1 with c, and with dp r and c minus 1, or another case is dp r minus 1 with c minus 1 plus, because we're going to choose it, and plus the previous value. So it's going to be nums 1 I minus 1 times nums 2 c minus 1. Yeah, let me just change a little bit. So here it's going to be nums r minus 1 times nums c minus 1, and another case is directly going to be this. So let me just copy it. Yeah, so this will be the 4 different cases. So the first case, the second case, and this case going to be, yeah, dp r minus 1, c minus 1 plus it, and the next one we don't need to plus it. Yeah, so that will be the 4 different cases. Finally, we just needed to return dp r minus 1 with dp minus 1 and minus 1. Yeah, so this is going to be the final result. Yeah, let me just run it to check. Yeah, because I needed to use this f. I forgot to use the f, and it is not dp. Maybe, yeah, maybe I'm gonna use dp. Yeah, now let's just check. As you can see, it works. Now let me submit it to check if it can pass. Yeah, as you can see, it passed, and it's pretty fast. Yeah, Normally for the DP formula, if we get a formula, maybe we can optimize a little bit. Basically, it will have no influence to the time complexity because the time complexity is m times n. It is 500 times 500. Yeah, but we can optimize a little bit. As you can see, there's a duplicate of nums. This one and nums 1 times nums 2. This one is the same. Yeah, so we can put it inside basically. Yeah. Now let's just put it inside. Yeah. Yeah, now let's just put it inside, make it a little bit shorter. So I don't need to plus it, I just need to use a max to check which one is bigger. Yeah, so this means if this one is more than 0, definitely I'm gonna use this one plus this one. But if it's less than or equal to 0, I don't need to plus it. So I can directly use a 0 to replace it. Yeah. I need to use a 0 with this one to replace it. So this is going to be the optimized code. Yeah, so this means this one and this one are going to choose the maximum, definitely. If it is negative, I'm going to choose 0. Basically, it means there's nothing. I just use this one times this one. So if this is more than 0, definitely I'm going to use the dpr minus 1, c minus 1 plus the nums 1, r minus 1, and nums 2, c minus 1. Yeah, this seems we makes the coding a little bit more compact. Yeah, but maybe it is not readable like before. But let me just submit it to check. Yeah, now as you can see, it also works. Thank you for watching. See you next time.